Welcome to 3D from Nothing, powered by Metalmite, the show where you will learn all about 3D printing and additive technology. I'm your host, Tom Jendick. Metalmite is a full-service machine shop that specializes in 5- and 6-axis CNC machining, CNC grinding, wire EDM, and 3D printing. We're a 50-plus-year-old corporation, started by my father, Michael Jendick III. I took over as CEO in 2009, and I'm continuing the manufacturing legacy today as a third-generation owner. In these programs, you'll learn what kinds of printers are out there, what kind of materials we can print on, who's using these printers, what kinds of things you should be looking to print, as well as hearing from experts in the field through interviews that we'll be conducting. As always, you can go to our website, 3dfromnothing.com, where there's some free giveaways. You'll learn about what we're doing and where that name comes from, which was my father, who said, one day we'll make parts out of nothing. And that's just what we're doing today with 3D printing and additive technology. Today, we're excited to bring Kevin Carr with us from Master Graphics. Kevin reached out to me on the web about a month ago, and we were able to connect. And Kevin's got his own podcast he'll tell you about, as well as a very unique business. Kevin, welcome to our show.
Thanks, Tom, for having me. I appreciate it.
Absolutely. Kevin, I'm really excited as you were telling me how you started your career in the 2D world with the design prints and the graphics, and then merged quickly into the additive world. And you were saying the two don't fully relate, but you've brought them together in one unique business. And you have a very successful blog and a very successful podcast. I've found value out of both.
Yeah, no, I appreciate that. So again, I'm president of Master Graphics. We're a Midwest-based company. And it's amazing, much like you, I think we've been around a long time. I think it's our 74th year. And it's interesting. So I've been at Master Graphics about 12 years and just took over the presidency about 2 years ago. And we started as a traditional blueprinter, which is interesting as you take this evolution. And so we've been traditionally in the 2D print space, think of engineering, CAD drawings. And then for a long time, we were a CAD Autodesk reseller. So you'll see where this fits into the 3D space. And over the last 10 or 12 years, we were not only a CAD Autodesk reseller, we sold wide format, but we started to dabble in 3D print. We actually signed up with Stratasys almost 25 years ago. It didn't really go anywhere. 12 years ago, 14 years ago, when I came on, we were selling Z Corp. And then Z Corp got bought by 3D Systems. And it was about that time I realized, hey, this is the growth, right? As a company, even like yours, we evolve over time. We got to get new technologies, that type of thing. So we really got serious about 3D print. And then in that time, over the last 12 years, have sold 3D Systems. Now we sell HP, we sell Ultimaker. So we've got a pretty wide breadth of products. And so even though we still have our core traditional 2D wide format business, our strength and growth has been around 3D. It's been an exciting time. And so, yeah, it's interesting. We run independently in silos in our group. But the one thing we've been able to leverage is the service techs, right? Because technology is technology. And then the CAD background has given us a lot of leverage on the design process. Now, since that, we've sold our Autodesk business, and I still got a partnership with those who have acquired it. But anyway, so yeah, we've just had this great evolution as a business. And now, believe it or not, 3D prints over 65% of our revenue. So
wow.
It's been a pretty big growth area for us.
Yeah. And so I think for our younger listeners, if we have any,
Yes.
I think you may have to explain what a blueprint is. I used that term the other day, and my oldest son, who'll be 21 here in 2 months, didn't know what I was talking about. Why would somebody want a print to be blue? You may want to explain what a blueprint is.
Well, amazingly enough, blueprint, and you may know this, but you probably had them in the shop when you were a kid, right?
Oh yeah,
It was actually it was an ammonia process. So my first job out of school was running a big ammonia machine, which was quite honestly pretty dangerous. We had a couple of ammonia links and had to leave the shop. So yeah, no kids don't know blueprints anymore.
Yeah. So basically it was a way for archaic people like you and I to make a copy of a drawing and offer it to others. We ran it through that ammonia machine. So I also used the term, someone said, "How are you?" "I'm good." And I said, "Ditto." And someone else said to me, what is a ditto? And so same concept. How did you make a copy back in the day with
that's right,
a ditto
I didn't know. Is that where ditto comes from? That's good.
It was a ditto machine. It was that was the guy's last name, but it was how you made a copy. It was, you had black all over it. But yeah, so I love the fact that the company, 74 years old, you said?
Yeah.
I assume you weren't there from the beginning because you look great for your age.
No, right, exactly right. No.
Whatever you're eating, I want that diet when we're done here.
In fact, I just hope it doesn't fail under me after 74 years. It's my biggest concern.
Oh yeah, there's the Lindy effect. I don't know if
Yeah.
you've ever heard of that, but the longer a company's been around, the more likely it'll stay around a long time.
Okay.
So
All right. I got that going for
yeah,
me.
you and I are both riding on the coattails.
Right.
53
Exactly.
years for me,
It
74 years for you. So
it is true though. Yeah.
so we start with the drawing, we move quickly into software, or not
Yep.
quickly, but maybe 30 years later, you move
Yep.
into software. Now software's driving manufacturing, additive
Yeah.
manufacturing. So I love the connection point of the business and how it's transitioned. Makes a lot of sense. There's a saying out, so we're in the Detroit area. I think you're just outside of Chicago, right?
Yeah. Yep.
So in the Detroit area, I don't know if this is a term all around the world, but they always say you don't want to be the guy making horseshoes when Henry Ford comes to town.
Oh yeah.
And so I use that term with my team all the time because essentially it's saying don't let technology pass you by.
Yeah.
And there's a lot of shops. So there was 1,800 shops in 2009 that closed their doors in in the Detroit area.
Yeah.
And we were able to survive that one. Now we got round two here with 2019. It seems like every 10 years we're hit with another COVID year or whatever. And if you're letting technology pass you by, you're not embracing these new things. And so certainly your company has embraced new things, from blueprints to digital software to actually manufacturing. So let's talk for a minute. As I pulled up one of your blogs, love the second blog I'm seeing on there about complementing additive and subtractive.
Yep.
And you and I talked briefly offline about, so there was this, I'll set it up and I'll let you take it from there. But there was this dichotomy that existed where subtractive machining, traditional milling and turning and grinding, is called subtractive machining. Additive came on the scene and there was this distaste for some reason. The traditional subtractive guys said, hey, we don't need these guys to come in and just print something and not need us and replace our skill. So then immediately the additive people said, we don't need these old school machinists who think they can, do everything better, and it's expensive and timely. So for some reason, the two industries don't like each other off the bat. And so take us in there to your blog. How are we going to get past that? What's the deal here?
It's interesting. I go back to even 3D print. I think at one point got overhyped, right? Like I think the biggest challenge we've had in the industry, it's totally exciting technology. And I think what happened is at one point, everyone in 3D was almost promising, right? We're going to get rid of traditional manufacturing. And it was really exciting technology, but I think we overhyped it. So then the true manufacturing guy at the time is like, wait a minute, you think you can do it better than me? I've been doing it 50 years this way. Mm-hmm. And so I think what happened is we overhyped it. You got excited about it. And then the traditional guys were, intimidated by it. But I think we're coming around where, as we actually talked earlier, if 3D print became 1% of the manufacturing industry, it would be a huge success, right? So I think to be successful, we're going to complement, augment, and make that better. In fact, even today, if you look at final use 3D printed parts, I don't have the fact, but it's something like what we consider final use parts in 3D print, over 40 or 50% are jigs and fixtures to be used in traditional manufacturing. So I think, like you said, sometimes what happens, what I think stalls actually the implementation of additive, is sometimes, like you said, we've overpromised and you don't see really where it can fit because we're trying to replace it versus augment. Again, it's been a passion of mine where you talk about the evolution of our companies and looking things differently, is to try to educate people and show them how the technology can practically work, but not totally change their process, because it's not going to happen overnight. Because metal, right, is another one. It's like the holy grail. Metal printing is still so reliant on finishing through traditional processes. Right. So the world's best metal printers really get finished with traditional metal solutions. That better than me, even, I think.
Yeah, and it's interesting because I just had that question earlier this week where a lot of people will call me and say, what tolerance can you hold on your metal printer? Yeah. And we have 3 metal printers and we have 4 what we call plastic printers, the nylons and the carbon fiber. And they'll ask me the same question on nylon, what tolerance can you hold? And I'm always a little perplexed because I'll say whatever tolerance you want. I'll print it, I'll leave some stock, and then I'll hone the hole, or I'll ream it, or I'll tap it. And so it's so natural for us to do both because we're looking to give a customer a finished product. And as I told you offline, we've even had customers, I say, hey, do you care if I 3D print that and then finish it? They've told me, I don't care at all how you make it. They don't even care. They find it intriguing. Hey, if you 3D print it, can you tell me how that's done? Or can you send me a picture? They think that's cool. But at the end of the day, whatever they've designed with the software that you're talking about, whatever you design, You just want this thing that you're holding to be there. You want those holes to be right. You want those. And that's another great reason that the two things you're looking at, I mean, you were starting to talk about Fusion 360 and how it's even got an option to, it'll tell you the best way to make it, right?
Yeah. Yeah, so two things on that. Like I said, on the finishing, what I would say is it's the dirty secret in 3D print. Look, I'm one of the most passionate people. 3D print makes it, shorter time to market, more innovative. But the dirty secret is the finishing part of 3D print. Mm-hmm. And so really traditional manufacturing is often that finishing touch to get where we want to go. But what I was talking about Fusion 360, and again, where I'm passionate about that traditional versus additive is the Fusion 360 added a generative design component. And what I, even again, in my own naivety, I always looked at generative design as being such the strength for 3D print. But Fusion 360 now has a generative design function where you can put in your parameters, it will create some designs, and then it will actually do a study on different processes, 3-axis, 4-axis milling, and it will actually go through a calculation of what the cost would be. And so it will actually output the best way to go. And just like we were just talking about, sometimes it's going to tell you traditional manufacturing, and sometimes it's going to tell you additive. But I think one of the other things where we were talking about just evolution of CAD, design processes have to change to leverage additive. And that's why I'm excited about tools such as Fusion 360. SolidWorks is continuing to evolve their product so that it does some of that workflow changes so that design is better. Right?
Yeah. Yeah, it makes a lot of sense. And the other good thing about you, we can jump right into the different offerings that your company has. I know you're a big HP distributor and also 3D systems. And then you said Ultimaker. By offering these different solutions, you are able to offer multiple ways of producing something. So you can talk a little bit about that. So HP, let's talk about them specifically for a minute. What's a range? Why would somebody be looking at an HP?
So where HP changed the market, Take SLS was always a standard bearer for a good quality plastic product. Mm-hmm. When HP came along is they really increased the throughput and the speed. Mm-hmm. So, and they drove the cost down. So I look at it as SLS on steroids.
Okay.
And what they allowed to do is really mass production. So now when that crossover point, it used to be, let's say 100 parts, it made sense to additive manufacturing versus going to tooling. HP moved that up, and it might be 200. It could be 10,000 parts. And so that's been HP's strength. So I said this many years ago. I think in the last, if you look at traditional 3D print, it's been FDM and then SLA is the standard bearers. And HP and then carbon. We don't sell carbon, but I'm a proponent of it. These guys got to it where the material property was a true kind of plastic part, and with properties that weren't really seen before. But HP's strength has really been that throughput for composite parts, for plastic parts, and just the way they've architecturally built the machine, it's built to scale up. So we have seen a number of actually really what I would say short run manufacturing companies pop up that we support. Take a Fast Radius, take a Re3D Tech, that are really short run plastic manufacturers, right? For certain applications.
So they skip the whole plastic injected mold idea. They go right to the HP machine. They're making production on it.
Exactly right. Now, again, as you were saying, Tom, it's a fit for some, right? Like I'm not saying we're replacing injection mold, but if you look at clips in some where you traditionally were waiting 10 or 12 weeks for a mold for 1,000 parts, you can print that out. Take Invisalign, right? Those are printed. The molds are printed using HP. So that's really what HP has done. That's pretty revolutionary. And again, there's been a couple out there. Carbon's another one. They do pretty high throughput. Properties are good. But HP's been pretty game changing. Yeah.
Now I've seen some buzz on the media. HP has this MultiJet technology. Can you talk about that? How is that different from what others have?
Yeah, so I talk about being oversold, right? And I think so eventually, if you look at the way HP works, it actually jets. Look, where HP made their money, it was like just our 2D. Their technology is based on jetting a liquid, right? So the way the MJF works is it puts a very fine layer of powder. It generally a PA12 nylon. It jets a medium that will make the material or the powder react to heat and melt. So where they talk about in the future is they're going to be able to do some processes where not only can they jet a medium to create fusing and actually melting, but they'll be able to do mechanical properties, maybe more flexibility, some electromechanical properties. So it's a little bit farther down the road. What they currently have done that's pretty unique, of course, is they jet it and they can actually put color in a product at a very high level. So that's really been their next step. But long term, if you follow where they want to go with it, is one of the other challenges with 3D print generally is you're printing in one medium. That's what you got to keep. HP believes with their technology, they'll be able to put, again, properties in those liquid chemicals to change what's in it. So you might have an electronic conductivity built in the middle of a part that will extend from top to bottom, and you won't have to assemble it. So again, I say this, Tom, I think it's a little bit, when they first came out, they were a little aggressive in it because their strength is now making mass quantity plastic parts, but that's where the technology will go. And you've seen some other people look at that. But again, it's like our cell phones. Who would have thought of that 40 years ago? And so obviously they have tested that technology, but that's where they get MultiJet Fusion technology from, is they can jet different materials to get different outcomes. And again, longer term, you'll see where they can create clarity on parts. They can create flexibility, not based on the material, but based on the actual liquid or chemical. Because the other thing, I don't know about you, you've learned in 3D print, so much of it is chemistry, right?
Yeah.
The technology is one, but so much of it is about chemistry.
For sure. For sure. Okay. With the HP, it looks like you have three main solutions there, that three main machines. Can you give us a little nutshell? What's the starting price range? Where are we ending?
So their strength has been, if you look at their 5200, 4200, our production workhorses built to print 24/7, thousands of parts, and they're not cheap. They're starting at 250,000 up to, $500,000. But again, they're truly production units where they include the printer, a build cart, which is also unique, right? So you build the print into a build cart. You can remove that build cart, put a new one in, and it starts right away. Where traditional 3D print, you got to remove it, you got to let it cool down, and then you have a processing station. And then they have the 500 series, again, more in that 80 to 120,000 range, is more of what I would call prototype semi-production. Again, same technology, so you're walking away with true PA12 nylon parts, and actually the lower version actually does color, but that's around. But like I said, they are truly built on production environment. They are like, again, the other thing, Master Graphics, we've generally dealt with more professional and production printers. Our expertise is not what I would call entry level printers, even though Ultimaker's on that borderline. But yeah, so their HP's real success has been around the 5200, is really the next evolution of the 4200, and it's all built about really short run manufacturing.
Okay.
Yeah.
And then you move into your 3D systems opportunities. So you have several printers there, and I know you specifically call out on your website the large scale printer. So let's talk about the regular 3D systems offerings first, then we'll go to that large scale next.
Well, so 3D Systems is unique because, right, they're really, if you find Chuck Hull was one of the ones who founded along with Scott Crump out of Stratasys. So 3D Systems, it's funny. So when we picked up HP, 3D Systems actually didn't allow us to sell their product anymore. So it was a big gamble 5 years ago. And I made an acquisition where they were a 3D Systems reseller. And fortunately, I knew I didn't burn my bridges. 3D Systems changed their mind, and they could see the value in someone like me who sells multiple technologies. But 3D Systems really has been the leader around SLA, plastic type parts. They have great SLS products. I was talking about how HP is SLS on steroids, but there's still a lot that SLS does that MultiJet Fusion can't do. They have some jetted materials, much like Objet has, where they're jetting an acrylic plastic. So 3D Systems strength is really, again, a wide range of technologies. They have one of the leading metal printers as well. So they've been an interesting one because one of the challenges I always love representing 3D is the systems is you could walk into a client and you could pick the technology that fit. Because a lot of times as you look at 3D print, it doesn't fit the application. And so HP, I was somewhat hamstrung because again, I don't want to say niche, but it's a very specific product. But 3D Systems, again, expands it because of the number of technologies they have and just their strength in history. So I know we were talking about it. They're big into medical with biocompatible materials. They do a lot of, if you take their metal, they have a bunch of units that actually print like knee replacements. So 3D Systems has done a really, if you look at even follow their results, they have a pretty large part of their revenue coming from medical applications. And that's pretty demanding, but they're a great partner to have because of their technology and just they've been in the industry for 30 years. It was Chuck Hull. I got a great story on Chuck Hull. So I actually met him at CES. And this is where maybe I get my think about the overhype. This was like 5 years ago. And he was an unbelievable guy. This guy invented 3D print. And I'm literally having a Corona beer with him sitting at some event. And it was interesting. He was on a panel and no one asked him questions on 3D print. Everyone was interested in Tesla and the self-driving car. And it was funny. I asked him, I go, how was that panel for you? You didn't get a lot of questions that people aren't, they not have questions about 3D print. And he said, you know what? It was actually a good thing because it shows that the hype cycle is kind of over and the real work is going to begin. And so it was interesting. He felt that even, right, like a perspective of it. But he was an unbelievable person. So, because I'd be like, my ego would be like, hey, ask me questions. And I do think, like I said, harping on that, have turned the corner where the reality of 3D print is more apparent than that overhype. But it was cool. It's amazing to meet the guy who basically founded 3D print to some extent.
Yeah, so I was going to say, can you give us a full background? I just pulled him up. So he's the co-founder, executive vice president of 3D Systems today, but he was one of the inventors of the SLA 3D printer. He was, what was his original company then?
No, I think he was originally 3D Systems. I think he started out in California and literally in his garage, and I cannot remember what company it was. And if he's a chemist, but he basically started taking light to cure photopolymer. That's where he started. Like that was the first additive. And then to give due credit to Stratasys, right about that time, because those were the two big players, 3D Systems and Stratasys. Some would argue it was maybe 4 or 5 months later, Scott Crump, and I hope I'm getting his name right, invented the FDM process of extruding material. But no, really, he was in his garage building this kind of vat of material, doing SLA, developed this company, and then that's where they were founded. So SLA, the standard bearer for production type printing. And then, of course, over time, 3D Systems expanded their technologies, acquired businesses, and then he stepped away for a while, and now he's just stepped back. But yeah.
I know 3D Systems, you can talk about this a little bit because we have a 3D Systems machine ourselves. We have the direct metal printer, the 300, which is selective laser sinter machine. Yeah. So 3D Systems, I heard this horrible story about 5 years ago that a person out of state, and I heard this from the software guy, he got funding and he raised like $3 million and he started a company from scratch and bought like 4 3D Systems machines. And his whole concept was no machining, no subtractive. And he was just going to make products for people and ship them. And he didn't invest in any software. And so at the time, 3D Systems sold him all these machines. He set it up. Well, here he was with his investment and he couldn't make anything. He didn't know how to do the support material. He didn't know how to design for it. So people were giving him products and he couldn't make them. So he was very frustrated. And at the time, 3D Systems had just started acquiring some of their software. I think at one point they had 3D Expert and then they had Cimatron, and there was all these mergers of software and hardware. And so today, I believe what I've heard you, and since you're a reseller, you can correct me. Today, you buy a complete solution, right? When you get this machine, you also get the software to do it all. So I think originally they were a la carte. I think you had to find a solution in software. You had to find a solution in hardware. You had to have a subtractive machine. So yeah, it was this other person's fault for not doing his research all the way through. But I remember at the time thinking, at least for us getting these machines, we already have software, we already have hardware, we're doing subtractive, and now we're adding additive. It's just a value add. But for somebody starting from scratch, that was a major oversight. It's like buying a Tesla and not getting any wheels with it. It's like, how are we going to do that?
No, and again, I've seen it all the time over the last 10 or 12 years. Companies pop up, they think they're going to buy a 3D printer and just print on it, but really the value, like you guys bring, is that design process and making sure you're using it. It's much more difficult than you would anticipate. I always say this, I do a lot of talks on 3D print. And the market's still relatively small. I think it was $15 billion last year worldwide. Apple sold 34 billion in 1/4 of iPhones. So a lot of people think they're going to get in, and there's just a lot more, as we talked earlier about 3D printing, the post-processing, the design piece of it. And you're right, one thing 3D Systems did very well was they would go out and they really wanted to get that design to product, whether it be software to the printer. And they had some challenges with some of the acquisitions, but that part they got. And you're right, now the way we print to or send images to printers is totally different. You got to calculate, you got to take into account how it's printing. And so that's definitely made some jumps. But yeah, I've seen that a lot where, I don't know, I wish I had the kind of money to just be like, all right, I'm going to invest $3 million in the industry I don't really know.
Yeah.
Just give me the money and I'll help you. But yeah, we saw it a lot. And as you said, I didn't realize you had the Pro X series, but metal printing is another one. I don't think people really realize the technology and expertise that's got to go in. The printer is only the initial investment. I would assume your investment around it is 2 times that to make sure that you're doing it effectively.
Yeah, if we hadn't had the 50 years of machining, if we didn't have 5 and 6 axis capabilities and software to support that, I don't even know what value it would bring to us. We just had a company that does gears on a large scale for all of the automotive makers. And they were here. So we prototype gears different times using the 5 axis. We'll machine it from solid. We went ahead and 3D printed out of miraging steel on that 3D Systems machine, some bevel gears. And so in order to print a bevel gear, you have to support it. So they don't understand that. So we left on a couple of the gears, we left the support structure at the bottom. And these engineers came in and we showed them a couple finished bevel gears. And they said, wow, you printed that? And I said, yeah. They said, it looks like a production part. And I said, it's miraging steel. It's 41 Rockwell. You can put it in your car and try it. And so again, it's trying to get them to understand this is a usable part. This isn't an SLA from 50 years ago. This is something you can try right now. And then they say, how do you make it? Then I pull the other one off the shelf with the support structure. Yeah. And they say, we can't use the part with all that junk on it. And I say, I know, that's why I machined it. And you have to literally show them 3 phases of this is how this gets to market because we had to do this. And so it doesn't seem all that difficult, but for some reason, there's this kind of mental block at understanding the steps of getting something to be usable.
Yeah, it's interesting. And it's why I love podcasts such as yours. I think again, going back to the overhype, if you looked at 3D metal technology, even when you bought yours or however long, 5 years ago, it has totally evolved in a lot of ways. And like I said, not so much the technology, but the things around it. And I think the other challenge is just like you, when you're trying to educate your customers, they had an experience where it didn't fit and it might not have, and they don't even understand the new capability. And that's what I said. I think that is part of our challenge is going back to where we were talking about traditional manufacturing coexisting with additive. The traditional manufacturing guy, of course, when he first saw 3D printing, it was comical, right? He can't compete, but they almost don't give it a second chance because that's what it was. And I think that's another challenge we have in the industry. And like I said, why I think just a talk like this is because, again, you got to look at innovative technologies to continue to grow, whether it be your business or our business. And it is one of the biggest challenges we have because in order to sustain and be around for 100 years like you guys have been, you need to embrace new innovative technology. And sometimes you get burned on that innovative technology, but you got to keep at it. And I do think that's a little bit of a challenge. I love that story just because you think engineers know everything, but again, they got so much information coming from the CNC guys, from the additive guys, from the finishing guys, that sometimes it's hard to tell. Yeah.
So that large scale 3D platform, the large scale, what's that about? How large can we go with that?
No, it's pretty big. It's 3 foot by 3 foot. Now, But again, the challenge I have with that, it's not atypical. There's big rep. So we represent it, but it's almost a hybrid between a consumer product and a large scale. But where it does is if you're doing big mock-ups or you're doing big templates, that's where it works. And really, it literally is just FDM, like an extruded material on a larger platform. Again, the time frame is longer, right? You do it, but it basically is taken that there's a few out there. 3DP is one of the better known ones, and it's really just for large scale. The finish isn't great, but the size is unmatched. So again, much like we see, a lot of times we'll see mock-ups where they print, like I have a gas tank for a motorcycle, not functioning, but what they did is they can mock it up for the form, shape, and fit and do that out. So it's lower, it's a lower priced item, again, for where we come from, $30,000, $40,000.
Yeah.
But its strength is, as the other limitation of 3D print is size, right? Like you can't print dashboards and stuff like that. Well, you can, like 3D Systems has some, but now you're talking $1 million machines. And that's where 3DP plays, right? In regards to those larger frame type prototypes.
Yeah. Yeah. And 3 foot by 4 foot. So, say anything, engine blocks, dashboards, armrests, all these things. It's a great way to do it. And like I say, very economical for $30,000, $40,000. Now, if we talk economical, you also sell the Ultimaker. So what are these for? Are these desktop units? Can guys make things at their desk? And
yeah, it's desktop. And again, it's interesting because I think this market, if you again follow it, these kind of entry level, it started with MakerBot, right? Is it made, once the patent expired to do it. But Ultimaker is what I would call is a prosumer product. You can go out and buy a $1,500 3D printer that works pretty well if you know what you're doing. Ultimaker just comes in all-in-one package where we can run a pretty wide range of materials. Unlike our HP where we're limited, I think there's 80 different materials we can run off a spool. Wow. And so Ultimaker is more of, I would say, that individual user prototype. Definitely jigs and fixtures can be done on it. And the other unique product that they have is they actually have a spool where you can line up, I think it's 7 different materials, and it will auto switch. So, the other challenge you have, and generally when you're doing FDM, is let's say you're doing a PLA or a PEEK or whatever, you generally got to change that material. It actually is a auto feeding system. So yeah, I would say they range from that $3,000 to $10,000 range. We see them big in education so that students can learn how to do it. And then in engineering departments, they'll have one for the engineers to do prototypes, jigs and fixtures, that type of thing. So it competes in that. Like I said, MakerBot seems to have gone by the wayside, but there's they compete with Markforged is another very great FDM type product, and that's where they fit. So what it allowed us to do it is, again, we were mostly on the production side, but there are times that engineer just wants something next to his desk so that he can print it, or in an engineering room. And it's, again, we found that at least we picked up Ultimaker because of the build quality and just overall support.
Yeah, it seems to me that I don't know a lot about that price range, but between $1,000 and $10,000, it seems that the difference is, number one, when you have an enclosed unit. I know we have 2 open air units, and then we have a couple closed units. The closed unit, you really want to keep that temperature a constant, because you're melting some sort of material and creating it through the nozzles. What would I see I don't know if your entry level Ultimaker is at about 1,500 or 2,000, you said?
Yeah, about $3,000, a little bit more.
$3,000. Yeah. And then your top end Ultimaker is less than 10 grand, right? Yeah. I think here. So what are the differences just from high to low? What would I see in quality?
Oh yeah. So again, like you said, the enclosure is the big one. And as you step up, it does a wider range of materials, because the 2 other things that matter in that space is the print head, right? What kind of, what's the diameter of the print head? What's the heat that it heats up to, right? So that you can do higher temperature materials. And then just the overall access system that it's using, is it? So as you step up, you get a better print head, better kind of material that you can do. And then as you step up to that higher one, that's where you get into the multi-feeding of the material, where it switches back and forth. So yeah, so you just, again, a lot of it's feature set, much like everything else that we do. Okay. Yeah, and it's interesting, you're right. I think the enclosure helps. Again, it's a pretty well-built system. And yeah, but that's it. Like a lot of it's materials, that type of thing.
Okay. All right. And then one of the last things I wanted to bring up on your website that I saw was this biocompatible materials. You referenced it earlier when you were talking about the Invisalign or the dental implements people are using. Now, I think you said there your products are being used to print the mold, and then they make the actual Invisalign that goes in someone's mouth out of a molded material. But I have actually seen, I think your blog talks about it, you can print things that are biocompatible that you can put in the body. Can you talk a little bit about that?
Yeah, again, this is more 3D Systems than HP, so I want to make that clear, right? So HP is not quite there because of their agents, but obviously there's a couple things we see. we talked about that, like the knee replacements, take the metal printers from HP or metal printers from 3D Systems. You can print knee replacements, and it's totally cool because what they do is they scan your knee before replacing, and then they can replicate it exactly how it was.
Wow.
So in theory, the way it works is your replacement is fit for your knee, as opposed to the old days, you would pick a size, the doctor would make it fit. And then the other big thing we're seeing is just surgical guides, right? So pre-op, there's this great, we talk about software being integrated. One thing 3D Systems also has, they have this great kind of virtual surgery software, not something I'm an expert on. But what they can do is they can create surgical guides, and obviously it's got to be able to have skin contact and all of that. And what that allows them to do is obviously be more effective in a surgery by using a guide for their surgical tools. And obviously we're also starting to see custom braces. You've seen obviously some prosthetic devices being developed. And so the medical's a big one. So like I said, on our HP side, it really hasn't been a strength outside of, like I said, the Invisalign, but that's really being used as the mold, not the final product. But if you look at 3D Systems, they've done some pretty incredible things when it comes to surgical tools and, like I said, hip joint replacements, metal printing it. So they have a whole division on medical that's pretty phenomenal. And that's another one. That's why I said, when you look at us and why we're living longer, that I think we're going to continue to see it. And then there's another great company out there in Vision Tech who does actually biomaterial. Like they have a bio printer. I'm sure you've seen it. Again, that's way above what I can handle. Let's worry about composites and in metal. But you're going to continue to see that type of stuff.
Yeah, we talked about that a couple episodes ago. We, at the end of this segment, I'll do it with you too, but we always do current events. We grab a couple articles and what's going on. But one of them was a company in Europe, I believe, is printing human organs and testing new medications on it.
Yeah,
so,
it's so
you know,
crazy.
not just biocompatible, but actual human tissue. So that's crazy. Before we go into that segment, Kevin, give all our listeners a way to find you. I mean, what's the best website? What's the best way to get a hold of you?
Great. You can go to mastergraphics.com, mastergraphics.com. My email is kevin.carr, C-A-R-R, at mastergraphics.com. And my phone number is 847-704-4025. Because I am passionate about the industry. So I always like talking to someone like you about it because I just get more educated myself. So yeah, feel free if there's anyone out there that's interested, or I'm sure I'll get some fact checkers out here that'll be like, hey, that's not right.
Yeah. Maybe Chuck Hall will call you up.
Yeah.
And say,
Oh my God. Right.
I
don't remember that conversation.
I don't drink Corona. So
I got a picture of that, Tom. So I do. It was a long time. Yeah.
You got it on. And I find you to be a little bit like the Santa Claus on Miracle on 34th Street, where you offer a handful of products, but you're talking about the other products in a complimentary way as well. Yeah. So it's good that your knowledge base, you've been around the industry long enough, value. And so it sounds like you're very approachable. If somebody wants to call you, you would counsel them with their exact needs. So that's a great aspect that you have.
Yeah, and again, to build off that, what's interesting is, Tom, and you have, like you said, the honor of leading a company. And one thing I've learned is before you're in this industry for 20, 30 years later, and I've really felt that it always comes back if you do the right things. We're, a big proponent of that the worst thing you can do is put the wrong solution set in a customer, because they'll never be our customer again. Look, I respect a lot of technology. I wish I could sell them all.
Yeah. When I started my career, which was about 25 years ago in this, they said, a wise old man gave me the advice, do the right things and do things right, and everything else will work out. So we keep it simple. That's fantastic. I appreciate your time today, Kevin. And like I say, as we bring up a couple articles here that I found, I'd love your feedback on it. Both of them will be in our show notes in the bottom, and I'll have links to it. But first one today comes out of 3dprintingindustry.com. Scientists 3D print a soft actuator on the basis of a jellyfish inspired robot. So again, we talk about soft tissue and synthetic items. It says researchers from the Japanese Yagamata University have developed a fully 3D printed actuator on the form of a jellyfish-like robot. Using a UV-based 3D printer, the team was able to cure the newly synthesized particle double network hydrogel. So again, crazy stuff happening.
Smart people out there.
Oh yeah,
Right?
thinking about a robot, an
Yeah,
actuator based on a jellyfish floating in the water. Great article, check it out there. It has all sorts of information on how they get this in there. For me, just picturing 3D printing, I'm trying to figure out, because we're melting and making something hard like plastic or steel, how are they finishing a water balloon, a jellyfish type substance?
Right. Just the
So
process of curing it or whatever they're doing. Yeah.
yeah, and how do you even think of that? How do you wake up
Right.
one morning and decide you're going to do that? So interesting thought there. The second one comes up from Ford and HP, so companies that you might, yeah. So my part of the world, the Ford family in Detroit, and your product, the HP, they team up to make F-250 parts on the 3D printer in order to reduce waste. So there's a whole article here talks about, from a sustainability perspective, one of the advantages of 3D printing is that it produces less waste than a traditional subtractive manufacturing method. So even in this article, they're starting to pit additive and subtractive against each other.
It's always a theme. It's a theme.
But even if you take away these old failed prototypes, the byproducts like plastic spools, everything ends up in a landfill. What makes the difference? Recent developments by Ford with the help of HP and 3 other companies, the automaker found a way to reuse the 3D printed powders and the parts in order to create injection molded parts. So what I find interesting about this is we joked about the additive subtractive pitted against each other, but they're not getting rid of injection mold.
Yeah.
HP has found a way to reuse powder and put it back into the injection mold to reduce waste. Again, this is a holistic solution. I don't know if you're familiar with any of that with your work with HP or.
Well, no, it's interesting because in fact, it's funny because we've been working with Ford. We're just talking to them about finishing side of things. And I did see that. And it's one of the things I should have mentioned earlier is HP, one of the other strengths they do is they reclaim a higher percentage of material than what traditional powder processes did. And yeah, they're all working. In fact, they do have one powder, and it might be polypropylene, I should know this, but it's 100% recyclable in the machine. So that is, yeah, no, it's interesting. So I'm not familiar exactly with what Ford is doing, but obviously, especially from a part perspective and others, we're starting to see more and more of that being done. But I love the sustainability aspect of it and in reusing it. Yeah.
Yeah, it seems a lot cleaner. And as we talked with some of the other manufacturers earlier this month, it seems like much of the 3D printing is very conscious of the environment and the byproduct and the gases and the different things being used. Love the fact that HP and Ford are conscientious of this. And it's funny, the article talks about the F-250 being one of the gas guzzlers that is being picked on, but yet the product they're using, they have a zero waste component in this whole process that they're doing with it. So again, links on the website. I'd love for you guys to check that out. And I'll have your contact information posted as well. But just really appreciate your time today, Kevin. Thanks for sharing with us.
No, it was great chatting with you, and you're doing great work on the podcast. So I appreciate having me.
Oh, and we should mention you have a friendly competitive podcast that we love. Yes. Tell us about that and how to find
That's right. Little did I know. So I have a podcast that I started calling Chatting 3D. Same thing as Tom, like it's meant to be educational, more professional, production level focused. So I would say it complements. We're trying to do the same thing. It's all about education and again, just having fun with good people from the industry. So again, you can look it up, either go to our website or go to Apple, but it's called Chatting 3D with Kevin Carr and Mark Bloomreiter is my co-host as of now.
Yeah.
But thank you for plugging that.
Absolutely. I checked it out. I loved it. I love your format. I love the conversation. All right. Thanks again for today. And we'll be talking to you again soon.
Awesome. Thanks, Tom.